Imagine the atom, a miniature solar system with a nucleus at the center and electrons orbiting it. It's a neat and tidy picture, but it's completely wrong. According to the rules of our everyday world, classical physics, this atom should not exist. The electron, a negatively charged particle, would be constantly pulled toward the positively charged nucleus. It would spiral inward, lose energy, and in a fraction of a second, the entire atom would collapse. But atoms don't collapse. So what's really happening? Why don't electrons crash into the nucleus? The answer is one of the most mind-bending ideas in all of science: quantum mechanics.
In the early 20th century, scientists were baffled by the atom's stability. Niels Bohr proposed a revolutionary idea. Electrons can only exist at specific, fixed distances from the nucleus, like steps on a ladder. This was the Bohr model. It was a game changer, but it was more of a brilliant cheat than a true explanation. It still treated the electron as a tiny particle in a fixed orbit and didn't solve the core mystery. The real answer came with the birth of quantum mechanics. This new theory threw out the old rules. Here are the three most important ideas. Electrons are not just particles. They have a dual nature, acting as both particles and waves at the same time. You can't pinpoint their exact location. Instead, their position is described by a probability wave, the uncertainty principle. This fundamental law says you can never know both the exact position and the exact momentum of an electron at the same time. If an electron were to touch the nucleus, we'd know its position perfectly, but this would make its momentum infinitely uncertain, an impossible state. The electron's wave nature prevents it from being confined to a single point. Atomic orbitals. Instead of fixed orbits, electrons exist in stable three-dimensional orbitals. Think of them not as paths, but as electron clouds or probability maps. An electron's lowest possible energy state isn't inside the nucleus, it's a stable, spread-out cloud that prevents it from crashing in. The atom is in a perfect balance, a state of minimum energy that keeps everything stable.
While electrons don't touch the nucleus in the classical sense, quantum mechanics reveals something even crazier. For some electrons, especially those in s orbitals, the probability cloud has a small but non-zero chance of being inside the nucleus's volume. This isn't the electron spiraling in, but rather its wave function having a tiny bit of overlap with the nucleus. This phenomenon is why a rare process called electron capture can happen, where the nucleus absorbs an electron. It's a real-world example of how the strange rules of quantum mechanics play out.
The atom is not a miniature solar system. It's a fascinating, complex cloud of probabilities, governed by rules that are totally unlike anything in our everyday experience. The very stability of the universe and our own existence is built on the bizarre and wonderful laws of quantum mechanics.